So I highly suggest you do not use anything you've ever learned before for this part of the lesson, or this part of the course. Usually when I teach something, I assume that you know something about it, but I'd rather you not know a darn thing, because usually what most people have in their heads is semi-right, semi-wrong, and therefore your answers are sometimes right and sometimes wrong. So I'm going to show you a method that is guaranteed to get you to the right answer every single time. It might take a little bit of writing, but it'll at least get you to the right answer every single time. Alright. Oh. So let's start off with conversions. Why isn't this writing? It worked earlier. Ah, it's way down here. That's not good. Unit conversions. So when we talk about unit conversions, they come in a lot of different little flavors. Some are simple, one unit to another. Later on, we're going to be changing what's called rates into other rates, or just simple rates into simple answers. So there's different ways of doing these things, but I'd rather you do it one way all the time. For instance, let's start off with how this works. If I tell you that x is equal to 5, nice little algebra statement. It's pretty simple. So if I had an algebraic equation, wherever you saw x, you would replace it with 5. That's pretty simple. But I want to do something else. What if I divided both sides by 5? What would I get?
X over 5
Equals?
1.
1. So I would say x over 5 is equal to 1. 1 in language is called a unit. So when we do these unit conversions, we're going to be using fractions that don't necessarily look like they're the same top to bottom, but they still equal 1. For instance, you know that there are 3 feet in 1 yard. I hope you know. I pray you know that there's 3 feet in 1 yard. So if I divide both sides by 3 feet, for the same reason that x equals 5 changes into x over 5 is equal to 1, 3 feet over 3 feet is 1, guaranteed. And this also, even though it looks really strange, is equal to 1. 1 yard over 3 feet is the same thing as 1. Just a simple 1. Not 1 feet, not 1 yard, just 1. And this is the basis of what it means to be a unit conversion. You take something that is equal to each other, like 3 feet equals 1 yard, and you change it into a unit without any measurement whatsoever. All right, so how do I use that in a change of things? For example, and I know you know how to do this shortcut-wise, but I want you to think about it the way I'm trying to teach it, because all the problems in that work for week 1 are based on all of this conversion stuff. And they are not simple. They are actually very complex, aren't they?
Yes.
Yeah. So, let's see here. Here's my first example. How many feet are in 5 inches? Keep it simple. I like starting off easy so you can see the pattern that we're going to be building, and then use that pattern to solve much more complex stuff. So how do we start this my way, or unit conversion way, or ratio conversions, or what else do they call it? Dimensional analysis. That's always fancy. I'm not going to set up a proportion, but that's another way of doing it. I'll teach you that next week, I think it is. This one I'm just doing unit conversions. So you start off with, this is what I have. So you write 5 inches. Since we're going to be doing fractional conversions, I want to write it as a fraction. So if it's a single value, you just want to put it over 1. Later on, we're going to have the word per in there, so something's going to go in the top and something's going to go in the bottom other than 1. But you need to write it as a fraction. We want to multiply this by another fraction. And what I want to happen is the inches to go away. So where would I put the inches, top or bottom?
On the bottom.
On the bottom. And you can kind of think of it algebraically that if there's one on the top and one on the bottom and it's multiplications, you can cancel, cross them out, right? And then in the top, I want to change it into feet. That's my goal. So you always want to know what you have, but you also want to know what your goal is, where you're going to want to end up, what kind of measurements you want in the very, very end. So what's the relationship between feet and inches? There are 12 inches for every
1
foot. So you go 12, 1. Since they're equal to each other, we can do this little step to them and create a big fat 1 out of it. All right, so here, if you want to think algebraically about it, the inches are going to cancel. The only unit left over, the measurement left over is feet. And the operation between 5 and 12 is obvious. One's on the top, one's on the bottom. So what's the operation? Divide. So either you get 5/12, or you literally type it in your calculator and get some kind of ugly decimal. I don't even know what 5/12 is as a decimal. But the only measurement left over is feet. So 5 inches is 5/12 of a foot. And of course you can change it to a decimal. So this is the pattern that we're going to do for every single one of them that we're going to do today. Eventually it's going to get really, really boring. But trust me, you're going to want to know how to do this stuff so the work for week 1 is simplistic rather than what the heck is going on. All right, let's try another little bit harder. Not much. I'm going to have to reset this whole thing. Okay. What is the information you need to know here?
Centimeters.
What do you know about centimeters and meters? Do you know how many centimeters are in a meter? Or meters in a centimeter? 1,000 or 100? I'll give you that much. It's 1,000 or 100. No one knows? What is a century?
100
100
years.
Century is 100 years. So a centimeter is?
100.
You need 100 of them for a meter. It's 100th of a meter. So we know that there's 100 centimeters equals 1 meter. 100 centimeters equals 1 meter. All right. So our fraction is going to be some relationship between this, either the centimeters on the top and the meters on the bottom, or vice versa. So the next thing you write is this number as a fraction. So you go 540 centimeters over 1. And you're going to multiply it by something that has what in the bottom. You're always getting rid of the centimeters, so you concentrate on that first. So if centimeters are in the top here and we want to get rid of them,
Meters.
centimeters at the bottom, so that they cancel. One on the bottom, one on the top. So therefore, what goes in the top? Meters. So what do I put where?
100 centimeters.
100 centimeters at the bottom and 1 meter at the top. And you know you did this right as long as this centimeter cancels with that centimeters and all you're left with is meters. So what operation exists between 540 and
100. Division.
division? So what's 540 divided by 100?
5.4.
5.4, and the measurement left is meters. Little m represents meters. Sadly, in physics, it represents mass too, so it gets kind of confusing when you get to physics. If you ever get there. Do you want to get there? Most people don't. It's a scary thing. How about this then? Let me erase this side. made this one up.
That's 75 what?
Kwan.
Kwan.
I made it up. Let's say there's a country that uses money denominations like Kwan. Well, Mexico uses peso. Japan uses yen. China uses... Oh, I don't remember what China uses. Huh, weird. Europe uses the euro. If you go to England, they still use the pound. It's very confusing. So I just made this measurement up, Kwan. So how do I find out how many Kwan are in $100 when the only thing I know is for $35 I can get 75 Kwan? So how do I start?
30.
I think you divide.
Don't guess. What's the first thing I want to write down?
Oh, the 100.
The 100. So you start off with $100, and since it's by itself, put it over 1. If it wasn't by itself, you put it over something else. All right, this is the basis of what we want to do, so what do we want to change it to? Well, the Kwan. So where's the dollars going to go?
The bottom.
The bottom. And where's the Kwan going to go?
It's
The top. Don't ever jump into, oh, I'm going to do a quick calculation and get an answer, because guaranteed half the time it's going to be wrong. Because there's two operations you could be using, multiplication or division, but in this case it's going to be both. One of each. So what do I write for the Kwan and the dollars?
75 over 35.
75 Kwan for every $35. If you're going to go to another country, you have to go to a bank and convert your money so that you can spend money in the other country. And every time they convert it, they just give you either more of it or less of it, or sometimes exactly the same. And this is how they do it, basically. Well, there's an easy way, but this is basically how they do it. So what's going to go away here? The money, the dollar. Well, this is all money.
Oh, $2.
One's in dollars and the other one's in Kwan, so it's still money. But the dollar symbol is definitely going to go its merry way. Now, how you figure out the rest is up to you. The unit that's left is the Kwan. This 100 is going to be multiplied by 75, but it's also going to be divided by 35. Depending on the calculators, I've seen do weird things. So if you want to be safe, 100 times 75 divided by 35. You could do 100 divided by 35 times 75. It should still give you the same answer. But I always like doing the multiplication first and the division second. Have it. But by the order of operations, it doesn't matter what order you do it in. So what's 100 times 75 divided by 35? 214 point
29.
28 or 29?
29.
Always rounding for money, 2 decimal places. And this would be in Kwan. Whatever the heck a Kwan is. Now these are all considered one-step conversions. Guess how many steps you could have? 2, 3, 4. It really depends on what unit you're going from and what unit you're going to. Some of them have 6 or 7 degrees of separation.
I hope we don't have a question like that on any of our tests.
Oh my God, do I? Yes, I do. But it's usually not a hard one. So those are all what's considered one step. Let's deal with...
I thought that was 2 steps.
Oh no. One step in this sense. You start here, and this is the first step. That is a one-step process. You multiply by one fraction. You could be multiplying by several of them. I'll have an example later on about that. All right, two-step process. What would be 2 degrees away from each other? Oh, this is a good one. how many seconds are in 1.5 hours? Now, the reason that this is 2 degrees of separation is to get from hours to seconds, you have to first go to minutes and then to seconds, unless you know how many seconds are in an hour. Not many people do. So, we start off with what we know. What do we know?
1.5 hours.
1.5 hours. So up front, 1.5 hours over 1, and we're going to multiply that. Now, if you don't know how many seconds are in an hour, you go to the mediary measurement, and the mediary measurement is minutes. So we want to get rid of hours, so where does it go?
The bottom.
Bottom. Where's the minutes go?
Top.
The top. And how many minutes in an hour?
60.
So you go 60 minutes for every single hour. But then we have to get rid of the minutes and change it into seconds. So then we set up another ratio fraction, a unit fraction. We want to get rid of minutes, because the hours are already gone. So the only thing left is minutes. So where's the minutes go?
At the bottom.
At the bottom. And then what goes up top?
Seconds.
Our goal is seconds. So you always want to keep in the back of your mind your goal. Your goal in this case is, I need a unit in seconds. So how many seconds in a minute? 60.
So did we supposed to cross out the hours? Like
Okay.
last time?
Yeah, I'm going to.
Oh,
You can do it as you write your fraction. I usually just do it at the end to
Oh.
make sure. You know, the hours are going to cancel here. The minutes are going to cancel here. And the only units left is
Seconds.
seconds. Oh, and I forgot to say, this method is really nice because you're never guessing at multiplication or division. It tells you exactly what you're doing. What am I doing all the way across?
Multiply.
Multiplying. No division whatsoever. So 1.5 times 60 times 60.
Like
5,400.
seconds.
Yeah, if you leave it like this, I'm going to be 5,400 bananas, apples, oranges. You have to give it something, otherwise it's just a number and it doesn't mean anything. And this is seconds. In Moodle, it's just S. If it has a unit space, it would just be S. That's a 2-step process. We can get worse. Well, I mean, it's still 2-step, but... How many gallons are in 200 ounces? Now, when I'm talking about, remember ounces? Ounces are that weird thing. There's a fluid ounce and then there's the weight ounce, but they're both called ounce. I always hated the ounce because you never know which one. Like if you're reading
Excuse me.
a recipe and they talk about ounces, some of them actually want you to weigh it and some of them want you to measure it. Now most of them want to measure, but some of these modern books are weight based, so they're really strange. So usually this is called a fluid ounce. But if you're talking about, what is this thing called? Does anybody know what kind of measurement a gallon is? What's it measure, basically? Like what's a foot measure? Distance, a length. It measures a distance.
Weight.
And what about this rug? How would you measure this
Volume.
rug?
Area.
Area, so that's length times width. This thing is
Volume.
one up from that.
Volume.
Volume. How much space is taken up. So a gallon is how much liquid takes up a certain amount of space. So this is a volume. Is a fancy word for it. We'll come back to that a little bit later on. All right, so how do I find out how many gallons are in 200 ounces? What do I start with?
Do you always start with the end amount?
The end amount. Well, the amount you know.
Yeah.
So we start off with,
Do we always?
if you know it and you want to convert it, you start with it. There are some other shortcuts, like if there's a mixture of measurements going on, you can start at different places, but we're only converting one thing over. What do I need to know?
How many ounces?
I have no clue how many ounces are in a gallon. Do you? 16. That's a cup. Or is it 8? I always forget. 8 ounces a cup. It's not that cheap.
The 16 foot.
The 16 fluid ounces is 2 cups. 8 ounces is 1 cup. But I want to change ounces into gallons, and this chart don't have it.
No.
So there's a few different ways you can go. There's not just one way of going. As long as you have ounces into something bigger, you're set. So which one do you want to use?
Can I have that chart?
You don't have one? Oh, why? Who else came in late?
Would
There
you
was
go
one
with
more, yeah.
pints or quarts?
We can either change it into pints or quarts. Which one sounds better?
Quart.
I would go for quarts, but pints wouldn't matter either. So if we go to quarts, how many ounces are in a quart?
32.
32. So when we set up our fraction, ounces is going to go in the bottom. I think you got that part pretty down pat. Up top goes quart. I'll just put QT for it. There are how many ounces? I forgot already. 32 ounces per 1 quart. But quart is not the end all. I want this thing to turn into
Gallons.
gallons. All right, so I'm going to multiply this by something. What goes in the bottom? Quarts. What goes in the top? Gallons. How many quarts are in a gallon? 4. Or 1 gallon. All right. So what goes away?
The ounces. and
The ounces
quarts.
goes away and the
Quarts.
quarts. So the ounces, 1 on the top, 1 on the bottom. Quarts, 1 on the top, 1 on the bottom. The only thing left over is gallons. So, what operation exists? Well, it's 200 divided by 32. In case you don't feel comfortable going divide on your calculator, do 200 divided by 32, get an answer.
Yeah.
Then take that answer and
Divide by 4.
divide by 4. Any number that's in the bottom is always going to be division. Any number in the top is always going to be multiply. So what's 200 divided by 32? And then turned around, divide by 4.
1.56.
1 point, there's more to it, I know there is.
2.5.
It's not that much more. 4 decimal places won't kill you. On Moodle, I usually round either to the nearest tenth or the nearest hundredth. It's one of the two, or the nearest whole, which is kind of. I even have one question that rounds to the nearest million. So, what's the measurement?
Gallons.
Gallons.
In case you're curious, I think there's 128 ounces per gallon. I think. I might be wrong. Okay. Let's go for multiple steps. Got enough room? I guess I can get out my knees and right way level. Let's do a multiple step one. Yeah. Yeah. How many seconds have I been alive? Now you can do this for your own age, but I'm going to use mine. It'll make the number really big. So, how many seconds, basically, are in 48 years? That sounds like a one-step process, right? I don't
No.
think so. So, start off with what we know. 48 years. Put it over 1. What do I want to get rid of? What do I want to change it to?
Get rid of the years and
Years.
change it to months.
Do you know how many seconds are in a year?
No.
Neither do I.
Get rid of
Days.
the years and change it to
Days.
Days.
Would probably be the easiest. So years goes in the bottom. Days go in the top. How many days in a year?
365.
365. If we want to be precise, 365 and a quarter. Why the quarter?
Because of leap year.
Leap year. Let's ignore leap year and just go with 365. It'll be a couple extra days. So 365. And that is for 1 year. Okay. So that'll get rid of the years and change it into
days.
days. That'll tell me how many days I've been alive. All right, now I need to change days. So what I want to get rid of is days. So that goes in the bottom. What do I want to change it to?
Minutes.
Don't do months. Months is weird because some months have 30, some months have 31, some months have 28, and then sometimes 39.
How about minutes?
So it's best to go right to
Minutes.
The minutes.
hours. I don't know how many minutes are in a day, so I start with hours. So how many hours are in a day?
24.
So you go 24 over 1. Right. Getting there. What do I want to get rid of next?
The hours.
Get rid of hours. So he goes in the bottom. What do I want to change it to?
Minutes.
Minutes.
Ah.
So how many minutes in 1 hour?
60.
60. Alright. And eventually I want to change it now into from minutes into
Seconds.
seconds. That's usually the easy one. And there's 60 seconds for every minute. Whew. How many degrees of separation is that? 1, 2, 3, 4. Alright, so make sure everything goes away the way it should. Years goes away, days goes away, hours go away, and
Minutes.
minutes go away. So the only measurement left from left to right is
60 seconds.
seconds. Is seconds. Now how do I find out how many seconds? They're all on the top. Multiply straight across. 48 times 365 times 24 times 60 times 60.
A lot.
A lot.
60.
1, 5, 1, 3,
1, 5, 1, 3,
7, 2,
7, 2,
8, 0, 0, 0.
8, 0, 0, 0. Put a couple commas in here,
That's a whole lot.
and this would be seconds. How do you read that number? Well, that's hundreds, thousands, millions.
Billion.
Billion. Billion before trillion. So this is 1.5 billion seconds I've been alive. Imagine if I got paid $1 a second. Are there people that make $1 a second?
Yes.
Easily. Ah. But that's still considered a simplistic conversion. Even though it has multiple steps to it, you're only changing one measurement into another one. So let's make it a little bit harder.
Is that 4 steps?
This one?
Yeah.
1, 2, 3, 4 degrees of separation. That's basically what it's called. Let's talk about rates.
So do something different.
Yes, no.
Oh.
I gotta teach you rates so we can convert, well, rates. So rates are kind of neat. Rates always have the word per. So can you think of any rates off the top of your head?
Per mile.
I mean, hard.
Miles per hour, MPH.
Miles per gallon.
Miles per gallon. You go to the gas station, it costs
Per
dollars per gallon. Another way of writing per is the fraction bar. So when you see fraction bars separating something, it's always read with
Per.
PER, per. Anything else?
Just seconds and hours. So we just do it. Can we do it?
Well, yeah, seconds per hour, but usually you don't say things like that. You just say 60 seconds in an hour or 60 seconds per hour, but that's more of a quality rather than a per.
Oh.
Rates are a little bit different. But I guess you could consider it a rate, but I wouldn't. It might just confuse the heck out of you. Nothing else?
GGTS.
Oh, I love GGTS. Does anybody know what other than you, GGTS is?
Drips per minute.
Drips per minute. If you're going into a medical field, you need to know GGTS. Never understood the abbreviation GGTS, but it works. DPM sounds better to me, but oh well. If you go to Canada, kilometers per hour or kilometers per hour, depending on how you want to say it. What's another good one? I wrote a couple down.
You say days per week.
Now, what that goes back to is just a simple, straight-up conversion. What was the one else? Oh, FPS. You will have a question on FPS in this class. No one knows what it is? Take a guess. So that's per in the middle.
Feet per second.
Feet per second.
Oh. It's ridiculous.
In metric system, it would be meters per second. But they don't write MPS, they write M/S, which is just a different way of writing things. All right, so these are all rates. Now you learned these back in, what would it be, 4th grade, 5th grade?
Yeah.
How to use certain rates. Let's talk about what you learned back then. I think they called it unit rates. And it's a way of being able to compare two different things measured in two different ways. So if you have something that is $1.23 per ounce, and you have something else that's $15 per pound, to compare these two, since they're written as different rates, you have to convert them into, well, the same rate. So either you have to convert ounces into pounds or pounds into ounces. So it's dealing with this mess over here. It's just now you have to deal with two measurements rather than one. You're always going to have a money amount, and you're always going to have a weight measurement. So which one do you think is easier, ounces to pounds or pounds to ounces?
Ounces to pounds.
Pounds to ounces. Now the reason that pounds to ounces is easier, it's always better to go from a big measurement into a smaller one. It'll keep your numbers
Small.
no, actually bigger than that they would have been. If you go pounds to ounces, it makes the number smaller, but sometimes it gets so small that it's really hard to tell what it's saying. Like say for instance, if I converted this, it became $0.00012. That's hard to work with. Where over here it might be 50 cents. Much easier to work with. So it's usually better to go from big measurement to smaller, usually. So we're going to convert him. Convert to price per ounce. We want to convert it to price per ounce. Now, when we were doing the regular conversions like this 1.5 hours, we would write 1.5 and put it over 1. Angels. So what we're going to do here is we can't just write $15 over 1 because it's not just $15. It's $15 per pound. 1 pound. So you have two things, well, sometimes you could have up to two things changing. You could be changing the dollars and you could be changing the pounds. But in this case, we really only want to change the pounds. So we multiply by a fraction. Where do the pounds go? At the top. We want those to go away. Opposite sides. And what do I want to change it into?
To dollars.
Nope, it's already in dollars. I want to change it into ounces. Remember, my goal is dollars per ounce. You always want to know where you have to end up. Otherwise, the measurements could be all over the place. All right, how many pounds in an ounce or ounces in a pound?
16.
16? That's one thing I hate about the English unit. The English unit is either 16, 8, or 4, or sometimes even 2. Where the metric unit is 10, 10, 10, 10 multiple times. There are 10 decimeters in a meter. There are 100 centimeters, or 10 centimeters per decimeter. There's 10 millimeters per centimeters. It's always 10. But the English unit is always all over the place. How many feet in a mile? A lot.
5,280.
I love that answer. A lot. Is a lot the same thing as a lot last class, which was a billion? I don't think so. How many? Do you remember?
5,280.
Pretty good. 5,280. How many kilometers in a? I'm sorry. How many meters in a kilometer? 1,000. Wow. Which one's easier to say? Oh well. So there are 16 ounces
Yes.
per pound. All right. So what goes away?
In pounds.
The pounds go away. Now your measurements left, there's two of them. The dollars from over here, and then the per ounce over here. Don't lose the word per, it's still in a fraction.
It has to be really small.
Dun, dun, dun. So, what operation exists between the 15 and the 16?
Division.
Division. So what's 15 divided by 16? Remember, this is money. So how many decimal places do you need? Two. So how much money are we talking about here?
0.02.
Say it again.
Oh, sorry, I was stressing.
Is it 15.00?
Nah, it won't be 15. It'll be point
94.
94.
What? Oh, I didn't even know.
Point 94.
Yeah.
Okay. But then there's that other measurement per ounce. So now when we look at these two prices, one is $1.23 per ounce. The other one is 94 cents an ounce. Which one would you buy?
94 cents.
94 cents an ounce. When I was growing up, everything used to come in, just basic small size. And then stores started doing those huge boxes of things, and a huge package of paper towels and all that fun stuff. Bulk. And it was cheaper to buy bulk back then. Stores got smart thinking that youth already figured out that they'd be cheaper, and they raised the prices on them. So it was actually cheaper to buy something smaller than bigger. But they already trained people to think that bulk was cheaper, so in your brain it was always
More.
cheaper. There was a law passed in North Carolina when I first moved here a few years back, 15, 16, 17 years ago, sometime back then, that grocery stores had to show unit prices. So what the grocery stores would do is they would have one being like 26 cents an ounce, like one type of soda, and then if you went from Coke to Pepsi, they would have the other one to be $1.38 per gallon. And there was no way of comparing them because one was measured in ounces and the other one in gallons. So they had to pass a second law to say that they had to be exactly the same measurements. So when you go to grocery stores now, if you look at the stickers, they're prices per ounce, price per can, price per unit. They have to be identical from product to product, as long as the products are similar. But the stores were smart because the first law just said you have to show unit prices. So they showed this unit price for one of them, and they showed this unit price for the other, which would tell you absolutely, unless you went through all this mess converting wise. But most people wouldn't even do that.
I use my in my head calculator.
Yeah, good luck calculating that in your head. Thank God for cell phones, right? They all come with calculators.
Yes.
But how many of you pull them out in the grocery store?
Sure do.
Really?
Sure do.
Oh, I never do. I guess I'm lazy. And I'm not really good with calculations
Only
either.
time I do this, that's the only time.
Christmas time?
Yeah.
Pull out that calculator.
So my big women.
I don't like doing
You heard that?
I don't like doing math.
that. Not in the grocery store.
Might make you look like a nerd.
No, it's
Save
not.
money.
Might make you look like a
just-
nerd. So we could do another simplistic one. A cord, chain, something, I don't know. Costs $8 per yard. I want you to do that one. I think I've pounded you to death on how to convert one unit to another. So you should be able to do it. Oh, come Thursday, you're doing this all on your own. And then, of course, your work for week one will also force you through it. Now, half of work for week one is really simple, convert one unit to another. But then it builds on itself and makes it, crazy stuff. So, a cord costs $8 per yard. How much will 20 feet of it cost? Oh, no, don't guess. Find out. Don't ever guess. Find out. Because I'll have half of you multiplying, the other half dividing, and therefore half is right and half is wrong. Don't be asking me questions, don't be raising your hand.
I got the answer.
I don't care.
I think.
I want everybody to get the answer. Especially those doing the work in pen.
Okay, we'll do it the right way.
Oh, yeah.
I forgot. Get it.
There are 3 feet in the yard.
That's true.
There are 3 feet in the yard. Here, I'll start you off. $8 per yard.
Oh, what's the off wrong?
Always start off with what's there, what you have. And you always want to write it as a fraction. I made it seem easy, didn't I? It is though. You have to practice. Oh, that's right. There's a second number I gave you, right?
Yeah.
I wonder how that plays in. But we'll leave it the way it is right now. I'll give you a small hint. I gave you 2 numbers. If you try to use them at once, you get it wrong. If you use one by itself, then more than likely you get it kind of right. I sneeze.
Bless you.
Thank you. So don't get confused between this, and the conversion. This is just 2 numbers you have to work with, but I highly suggest you only work with one of them. Kind of like this $1.23 per ounce and $15 per pound. I chose one of them and I converted it into the other. So I highly suggest you either choose $8 per yard or the 20 feet. I think $8 per yard is easier. That's why I wrote it. Oh, I need a tissue. Oh, that's nice.
1020.
Now, sometimes I don't expect you to finish these, but I definitely want you to be thinking about them instead of just copying stuff I put on the board. So what would you do with $8 per yard to at least start this problem?
Get rid of
Yard
the
is a fee.
Multiply by
yard.
yard at the top, feet at the bottom. That's an awesome start because it gets rid of yards and changes it into
Feet.
feet. Okay. So how many yards in a foot?
3 feet.
Obviously you didn't listen to my question.
1 yard.
1 yard in every
3 feet.
3 feet. I love asking questions that people don't answer right. So what goes away?
The yard.
The yards. Now I'm not going to multiply by anything else. I'm going to do this as a 2-step process. If you get rid of the yards, what's left?
The feet.
The feet and
The money.
the money. So this is going to be dollars. How much dollars?
8. No, excuse me.
8 times.
Say that again.
8 times 4 divided by 3.
Or just 8 divided by 3.
Yeah.
2.66.
2.66.
6, 7.
7. Always round when the decimal to the right is bigger than
5.
5 or bigger. 5 or bigger. Now this is 267 per
Feet.
foot. Now can you answer my question?
So you gotta do 8 times 1 divided by 3.
Well, 8 times 1 is just 8. Don't just multiply by 3. So technically, any number on the top is divided by any number on the bottom. 1s don't count. You can ignore 1s because 1 times anything is anything.
So you do 8.
Divided by 3. And 8 divided by 3 is 2.66666666, but we're rounding.
So if we do this on a computer, is it gonna, we're gonna have to put per feet or the slash? It
Well, some of these it'll just say next to the box per foot.
oh, okay. It already has.
If I want you to put the unit in, it's kind of hard for that one because technically the unit is dollars per foot. But usually you put the dollars on the left and the foot on the right. Some units you put everything on the right.
Oh.
Now if it's one that everything's on the right, I'll do it that way. But generally I'll put You might have to put the dollar, but I'll put the because it's just easier to, because I can't get the computer to recognize a front and a back. It either recognizes front only or back only. It's weird. Okay, so what can I do with this number to get to my cost of 20 feet? Well, you take our 20 feet now. 20 feet. Now, what do I put it over?
The
267.
one.
1. Because 20 feet is an individual number that we're trying to find something out about. This is another, this is not necessarily conversion, this is actually finding the cost of something. If you pump gas into your car, this is what happens. So, what do I multiply by? Well, I want to get rid of feet. You still want to concentrate on the unit that you want to get rid of, because sometimes you have to take this number and flip it. You know, put the 267 in the bottom and the 1 in the top. Not in this case, though. What goes in the top? Well, $2.67. So here the feet are going to cancel, and we get 20 times $2.67 for a grand total of
$53.33.
$53.33.
33 cents.
33 cents?
I got 44.
30.4.
Let me do this again.
I don't trust any of you. It's a calculator. Push buttons.
53.4.
Yes, 53.4.
Point 4. Point 4.
Only.
Yeah.
It's
Okay.
If you round it,
It'll be
the first number, would you use those?
The next number is a 3, you're gonna run down to my greater than 5.
Yeah, but all I'm looking for is 2.67 times 20.
It's 53.4.
Yeah, but is that how you're going to write it?
No, that's 53.
No, because it's money.
$53. $53.
And 40 cents.
Ah.
You're right, $53.4, and people are like, what? But you, for people, they need that 0. In Moodle, sometimes that 0 gets dropped, and you have to kind of put it in, so be careful with that. So this rug is going to cost $53.40. All right, rug. This cord is going to cost $53.40. Not bad. Okay, break time.